This is General Chemistry 1. And today, we will be talking about the first part of our stoichiometry, a series of discussions on stoichiometry. So for this afternoon, we will be talking about mole concept, molar mass, and Avogadro's number. Okay. So I hope you have heard these words already during your junior high, if ever. And we're just going to um, discuss elaborately on them this afternoon. Okay? So, how many is a mole? Ayan, how many is a mole? Alright? Sabi dito, atomic mass units in real situations is not usable. Why? Oh, if we because we are dealing with substances with enormous amounts of atoms. Okay? So, ano ba bakit hindi usable yung atomic mass unit? Remember when we discussed last time yung subatomic particles? What were the subatomic particles that we discussed earlier? So we had the electrons, we had the protons, and then we had neutrons, right? Electrons, protons, and neutrons. And in our discussion, I presented to you a table that gives you the actual masses, the actual charges of these subatomic particles. And you can see that because the actual masses of the subatomic particles were very, very small, okay, na it's very difficult to handle that kind of a number, we assigned a mass unit. So since we have seen that the mass of a proton is equivalent to the mass of a neutron, then we assigned a unit mass for each of these to be 1. Okay, and then we have seen also that the mass of the electron compared to these two subatomic particles are what? Negligible. So we just assume that the mass of an electron is negligible compared to the mass of a proton and a neutron. So we always assume electrons to be massless. All right? Yon. So in this case, we use a special unit to describe a large number of atoms. Kasi it could be that one atom has these subatomic particles, but for a piece of an element or a piece of a compound, okay, we're not talking of just thousands, okay, or millions or billions of atoms in a piece of a matter, but more than that. And so it's so great and so enormous an amount that we will be able to handle it using those values. Okay, so we assign a quantity that will describe with a unit that will give us a certain amount for any substance. In fact, sabi dito, this idea is not new, but this has been used extensively already. Like for example, di ba, a pair. O sabi natin, pag sinabing pair, we always think na dalawa yan, di ba? Kaya pag sinabing a pair of shoes, hindi pwedeng isa laang, yung kabaak lang or kahati lang, alright? But it's always two items together, di ba? A pair, a couple, o ito yung mga which means two, di ba? Century, 1 century to mean 100 years, okay? Or 1 dozen to mean 12 items. O so, ganun din, a mole, okay, gives us a unit. Yeah, sabi doon, for atoms, the SI unit is the mole. Right? In symbol, it is mol. O, M-O-L. Yan yung symbol niya. Like grams, the symbol is G. Diba? Kilograms, the symbol is kg. Or meter, the symbol is small letter M. And so on and so forth. So for a mole, it is this, ito yung kanyang symbol. Alright. Yan. So, what is a mole? How many particles are there in a mole? Okay, so just like a dozen means 12 items, a century means 100, or a millennium to mean 1,000 years, a mole, okay, of any substance is the amount of substance that contains as many elementary entities as there are atoms in exactly 12 grams of the carbon-12 isotope. Alright, so, ibig sabihin, ito yung pinagbasehan ng pagkuha ng value for a mole of a substance. For all you know, lahat ng ating mga quantities, mga units, meron niyang mga pinanggalingan. Like for example, yung second, di ba? Meron niyang pinanggalingan. The meter, meron niyang pinanggalingan. The kilogram, di ba? And lahat ng ito, like for example, the kilogram, I think if I'm not mistaken or if I remember it right, is a certain um, uh, metal or something na yun yung parang pinakang standard. Kaya pag nag-standardize ng mga equipments, ito yung mga pinagbabasehan. Alright? And all of these quantities are based on properties pa din. Okay? That you find in nature which do not change. Okay? Na hindi nagbabago. So, yung mole, hindi yan basta yan magic na sinabi, ay sige, ito ang mole, ito ang kanyang ganyo value. No. Okay? So, merong pinanggalingan at ito nga yun. Alright? That's the one. So, 1 mole of any substance is equal to 6.022 times 10 to the 23 particles. Okay. So, sinabi nating substance, and we have learned from previous lessons that substances are either elements or compounds, right? A substance could be an element or a compound, and 1 mole of it contains this much number of particles. And this value is called the Avogadro's number. Constant yan. Just like other constants that you know, di ba? Yung gas constants and other constants in nature, di ba? Yung things like that. Yung the boiling point of water is also constant 100 degrees Celsius. Others. So, pag sinabi natin Avogadro's number, we know that it is this value. And it represents the number of particles for 1 mole of any substance. O, di ba? Okay? O, kaya lang, syempre, kaya ba nating bilangin itong number na ito? Can we count this one? By the way, pag sinabing particles, depende yung kung ano yung particles, kung ano yung substance. Like for example, if it is an element, then the particles are the atoms. Okay? And if it's a compound, the particles are the molecules. Alright? So, yun yun. Okay. So, Avogadro's number, therefore, represents the number of atoms or molecules in 1 mole of an element or compound. O, diba? So, like for example, 1 dozen. It could be 1 dozen egg. It could be 1 dozen chairs. It could be 1 dozen students. It could be 1 dozen houses. Oh. So, basta alam natin 1 dozen is 12 items. Did you get that? O, dito naman, alam natin whatever the substance is, basta 1 mole, ganyan kadami ang number of particles. Okay? Is that clear? Can I get a thumbs up if that is clear? Okay, thank you. Alright, so let's continue. Yan. So, molar mass of atoms. O, sige. Counting by mass can be applied to large quantities of atoms. Okay? O kasi, ganito yan. O, so, we're going to use an analogy para mas madali niyong maintindihan. Alright, ganito yan. Kunyari, ikaw ay, ano nga ba ito? Junk shop owner. Right? And then, di ba, kung junk shop owner ka, bumibili ka ng mga, let's say, lata. Okay, lata. Kunyari, lata ng gatas. Kunyari, sinort out mo yung lahat ng lata ng gatas na pare-pareho. Okay? Eh, ang dami. So, instead na bilangin mo isa-isa, ilalagay mo na lang sa isang sako, tapos titimbangin mo. Alright? Tapos sa timbang, malalaman mo kung ilang pirasong lata. Di ba? Kasi alam mo kung ano yung timbang ng bawat isang lata. Right? So, this analogy could be seen this way. Alright? Oh, so you know that every can weighs 10 grams. Tapos nung nilagay mo sa sako lahat, tinimbang mo, isang timbang lang, it turned out to be 1,000 grams. O, di ba? Isang measurement lang. Isang measurement lang, the mass. Instead of counting the cans one by one. You get that? And since you know that 1 can equals 10 grams in terms of its mass, o ito yung factor na i-multiply natin, okay, sa 1,000 grams to get the number of cans. So, performing the operation, okay, 1,000 grams multiplied by 1 can over 10 grams equals 100 cans. O, di ba? So, you don't have to count the 100. So, ganun din. It's the same manner as in counting. Okay? O, kasi wala naman, how can you count atoms, right? You don't even see atoms. But, sige, tingnan muna natin. But, going back, sabi natin, the atomic mass unit of each atom, okay, is based on the actual masses of the protons and neutrons. O, sige, let's read this. The average atomic mass for an element is calculated by summing the masses of the element's isotopes, each multiplied by its natural abundance. Okay, so let's see. This example, we have a chlorine atom here. Oh, remember this itong symbol na ito? Okay, this is the atomic mass and this is the mass number. And then we said that the mass number gives you the composition of protons and neutrons, right? And looking back, the actual mass of a proton and a neutron are equivalent. Okay? And then the mass of the electron is assumed to be negligible. So parang massless lang. So, ibig sabihin, in other words, the mass of this chlorine atom here, okay, ay galing dun sa neutrons and protons. Kaya 35. Okay? Yan. Kaya lang, pag kumuha tayo ng actual sample, okay, from the environment ng chlorine, hindi lahat yon ay chlorine na mass number ay 35. Meron ding chlorine in nature na 37 yung isotope. But in terms of abundance, okay, on the earth or on Earth's surface or kung saan man siya natatagpuan, chlorine 35 is 75% abundant and chlorine 37 is 25% abundant. Yan ang ibig sabihin nun. Alright? In reality, the chlorine sample that we can get from our environment does not have an atomic mass na 35 or 37 alone. But, alright. So, following this operation, 35 times 0.75, saan galing yan? From from chlorine 35, and that is 75% abundant. So, this gives you 26.25. 37 galing dito times 0.25 galing dito, you have 9.25. Adding the two, this gives you 35.5. And this is the atomic mass unit that you can find in your periodic table. So, ibig sabihin, average na yan. This is the average atomic mass unit of all of the isotopes of chlorine, okay, that you find in nature. Kaya makikita nyo sa periodic table, wala namang nakalagay atomic mass ay 35 lang o 37 lang. Hindi, di ba? Kundi 35.5. Kasi yan na yung average atomic mass unit, and this was obtained from the average percentage abundance present. Okay? Abundance of the isotopes present on Earth. Alright? So remember that, ha? So makikita nyo, if you look at other elements in your periodic table, or like for example, nitrogen, wala dong nitrogen na 15 ang atomic mass unit, or 14, di ba? Kundi 14 point something, or like for example, yung chlorine, yung oxygen, di ba? 15.99. Oh, we just round it off for during calculations into 16, di ba? Tapos yung iba, yung carbon, instead of 12, it's 12.01 or 12.012. Oh, because this is how the average atomic mass units of the elements were obtained. Okay? Is that clear? Is that clear? Can I get a thumbs up again if it's clear? Okay. Thank you. Very good. Alright, so let's continue. Ayan. So counting by mass can be applied also to large quantities of atoms. Okay? So you can see that from the periodic table, you can find the atomic mass of an atom in atomic mass unit. For example, one atom of aluminum is 26.98. O again, okay? Paano nakuha yung 26.98? Pareho nung kanina dun sa chlorine. Okay? So this is obtained from the relative abundances of the aluminum isotopes. So this is average, 26.98. Right. However, because it is more convenient to measure mass in a balance, o di ba? Wala namang tayong measuring device to measure atomic mass unit, or you cannot really count the number of atoms present, di ba? So it's always best to measure in terms of a weighing balance, weighing scale. Okay? So let us find out how the atomic mass units compare with the mass in grams. Okay? Let's continue. So by definition, sabi natin, one atomic mass unit equals 1.66 times 10 to the negative 24 grams. Saan galing nga ito? Diba? Dun sa actual mass ng mga subatomic particles. Remember that? During our last discussion? Okay? Yan, naalala nyo? Yan. So, if that would be, kasi may mga atom na walang neutron, isang proton lang ang nandun. Oh, so, that would be hydrogen. Diba? Yung hydrogen na 1 ang mass number. Kasi merong hydrogen na 2 ang mass number. Okay? So, if it's a hydrogen na 1 ang atomic number, then it has only a proton in its nucleus. And this is the actual atomic mass unit, 1.66 times 10 to the negative 24. Ayan. Okay? You get that? So, 1 atomic, ayan. This is the actual mass. Kaya lang, kung hindi natin kayang i-measure itong value na ito in any weighing balance or weighing scale, sobrang liit niyan. Siguro up to the milligram level lamang. Alright, so therefore, the mass of one atom of aluminum in grams is, kung ito yung 1 atomic mass unit, and you have 26.98 atomic mass unit, that's the average atomic mass unit of aluminum. Tama? 1 atom is 26.9. That's the average. Okay, and if 1 atomic mass unit is 1.66 times 10 to the negative 24 gram, therefore, the mass in grams, okay, of 1 atom of aluminum is 4.48 times 10 to the negative 23 grams. Okay? Times 10 to the negative 23. Yan yung actual mass ng isang atom of aluminum. You get that? Okay, so let's continue. Now, suppose you have 26.98 grams of aluminum. Hindi na yan yung atomic mass unit. Kundi yan na yung nag-measure tayo. Kasi pwede na natin yung timbangin. 26.98 gram of aluminum. Okay? And then you want to know how many atoms are present in 26.98 grams. Alright? Okay, so looking at this, alam naman natin kanina, na-calculate natin na yung mass ng 1 atom of aluminum is 4.48 times 10 to the negative 23 grams. Okay, you got that? Kanina, yung kinumpute natin. And then we weighed 26.98. Okay, multiplying that, this gives you 6.02 times 10 to the 23 atoms of aluminum. Okay, what do you notice here, class? What do you notice? Sige nga. What do you notice? Anybody? The number of atoms that we obtain gives the Avogadro's number. Tama ba? Okay? Notice that the average gives the Avogadro's number, which is actually the number of atoms, okay, of 1 mole. Yan. Of silver. Aluminum. So the molar mass of an element, therefore, is the mass of 1 mole of that element. Okay. So, kanina, on a per atom basis, this 26.98 grams, okay, is 26.98 atomic mass unit per atom. But if we collect this much number of aluminum atoms, then we get, okay, the mass. And since sabi natin kanina, 1 mole of any substance contains this much number of particles. Therefore now, this 26.98 grams gives you the mass in grams of 1 mole of aluminum in this case. Okay? Nakuha nyo? You get that? So sabi natin kanina, kung bibilangin natin, o pabalik tayo dun sa lata, di ba? Kesa magbilang tayo ng 100 cans, mas mahirap di ba? Mano-mano. Mas madaling magtimbang ng isang beses lang. Tapos calculate na lang kung ilang piraso yun. Okay? So, it's the same manner here. Di ba? It's the same manner. Timbang tayo ng ganitong grams. Okay? And then you notice that it gives you this much number of atoms. And this mass, therefore, in grams is the mass in grams of 1 mole of aluminum. And we call it the molar mass of aluminum. So to generalize, generally now, the molar mass of an element or any substance for that matter, okay, is equal to the mass in grams of that substance. Okay? The mass of 1 mole. Okay? And 1 mole, ganito kadami. O, di ba? Kaya kung alam natin yung molar mass, alright, we will be able to determine kung ilang atoms. Di ba? Or ilang molecules. Okay? So, moving on. The molar mass of an atom and molar mass. Sige, tingnan natin. So, the molar mass of aluminum is 26.98. While the mass of one atom is 26.98 atomic mass unit. Right. So the two values, you notice, okay, are the same. Okay, so we can now conclude that this relationship is true for all the elements. Diba? Kaya in other words, the mass in grams of 1 mole of atoms is numerically equal to the atomic mass unit of those atoms. So in other words, all of the atomic mass units that you can find or that you can see in the periodic table for all the elements, you can also take them or consider them as the mass in grams of 1 mole of those elements. O, diba? So, in other words, the periodic table could be a reference not only for atomic mass unit of an atom, but also the molar mass of the atoms. Okay? Is that clear? Maliwanag ba? Can I get an answer? Okay, thank you. Very good. All right, so moving on. Tingnan na natin. Stoichiometry. Sige nga, let's see. Let's have one example. How many moles of carbon are in 26 grams of carbon? Okay. Class, this kind of computation, you call this factor label method because you have a equivalence, okay, which you use as a factor. Okay? So, pwedeng pagpalitin yan, ha? Pwedeng 12.01 gram over 1 mole or 1 mole over 12.01. Depende sa i-compute. Okay? Depende sa given. Okay? So, here, you're being asked kung ilang mole daw ang 26 grams ng carbon. O, di ba? We know that the molar mass of carbon is 12.01 gram. Okay? So, that is for 1 mole. But you have 26 grams here. So, performing the operations like this, okay, 26 grams carbons multiplied by, so this is now our factor. Saan galing yan? From this relationship. Okay? Yan, from this relationship. And carrying out the operations, we have 2.2 mole carbon. Okay? So, 26 grams of carbon is equivalent to 2.2 moles of carbon. Okay, can you see? Is this clear? Let's have another example naman. Another one. Yan. This time, you're being asked, what is the mass in grams of one atom of carbon? Di ba? Kanina, doon sa example natin, what is the mass in grams of one atom of aluminum ba yun? Aluminum yung nakita natin. And we have this relationship. Di ba? And 1 mole contains this number of atoms. 1 mole is equivalent to this mass in grams. Then, therefore, sorry class ha, this should be times 10 to the 23, not negative, okay? Kasi ito yon ha. Nagkamali lang ako, sorry. Sorry about that. Okay? So, this is the value. So, carrying out the operation, you get this. So, this is now the actual mass in grams of one atom of carbon. Okay? Is that clear? Can I get a thumbs up if it is clear? Anybody? Okay. Okay. All right. Thank you. Very good. Sige nga. Now, this is for the atoms. What about for molecules? Okay, the mass of molecules. Yan. So, 1 mole of a compound contains the same number of particles as 1 mole of an element. Kaya even if it is 1 mole of aluminum, 1 mole of carbon, or 1 mole of H2O, or 1 mole of CO2, all of them contains the same number of particles. Pag compounds nga lang, molecules siya. Right? Kaya lang, paano natin kinukuha yung molar mass? Wala naman nakalagay sa periodic table na CO2 or H2O. Diba? So we do that by just adding the atomic mass of each element in the compound multiplied by the subscript kung meron. Okay? So let's have an example. Right. Ito. Although O2 is not a compound, it is a molecule. Kasi O2. This means an oxygen atom bonded to another oxygen atom. Okay? So ito yung sinasabi ko sa inyo last time na molecular in nature, but it is not a compound. Okay? It is an element. Why? Because it consists only of one kind of atom. Okay? Ayan. So, anyway, balik tayo sa pag-calculate ng molar mass. So, oxygen, the molar mass of oxygen atom is 16 grams. But you have 2 here. Subscript. Yan yung subscript na sinasabi ko. Kaya times 2. So, is equal to 32 grams. Kung yan ay O lang, oxygen lang, walang 2, then it is 16 grams. Ito yung makikita ninyo doon sa inyong periodic table. Okay? But I think in the periodic table, it is 15.999. But you can round it off to 16 grams for calculations. Alright? Another example. Ayan. So what is the molar mass of carbon dioxide or CO2? Okay, so the molar mass of carbon is 12 grams. But times 1 because it has only 1. Pag walang subscript class, it is understood to be 1. Kaya times 1 equals 12 grams. Then oxygen, 16 grams times 2, dahil may 2 doon, 32 grams. Alright, so, ayan. As I was saying earlier, what is the molar mass of carbon dioxide? So, ganun lang. It's just like that. You just add up the molar masses of each of the atoms present in the compound multiplied by the subscript, if there is any. So, with this, on adding that, we get 44 grams. So, that means for carbon dioxide, the mass in grams of 1 mole is 44. Okay? 44 grams. Yan yung ibig sabihin yan. Alright? Any questions? So, yeah, let us see. Let's have some exercises. Ayan. On your seat, so parang nasa classroom ano. Okay? Calculate the molar mass of each of the following. Kasi pag element, madali lang eh. Tignan mo lang sa periodic table, yun na yun. Wala nang computation. Okay? Kasi nga, kung ano yung atomic mass unit, yun na rin yung molar mass in grams. Okay? So, what is the molar mass or the mass in grams of 1 mole of NH3? NH3 class is the formula for ammonia. O sige. On your seats, kung saan man kayo ngayon, please calculate what is the mass in grams of 1 mole of ammonia. Come on. And then write your answers on the chat box. Okay. Pag sa classroom to paunahan lagi estudyante ko. The first one to give the correct answer will always have a bonus point sa quiz. Okay, so anybody? Wala bang nagko-compute? I hope you're computing. 17. 17.03. Okay. The others? Wala, dadalawa nag-compute. Okay, the correct answer is 17 or 17.03 is correct. No problem. Alright? So both, basta as long as when you round it off, it's 17. Okay, yan. So alam na, no? What about NH4NO3? Now, NH4NO3 is the formula for ammonium nitrate. So what is the molar mass of, or the molar mass in grams of ammonium nitrate? Oh, come on. I'll give you a few seconds to solve that. 80.04. 80.04. Oh, dadalawa ba ang estudyante ko? Okay, very good. So the correct answer is 80. 80.04 is correct. 80.043 is correct. Okay, as long as when you round off the answers, it is 80. Okay, so maliwanag na yan. Alright? So, in computing naman for yan. So, by the way, when you calculate for the, tawag dito, the number of moles, or it's the same procedure as that we did for the elements. Ang naiba lang naman yung pagkuha ng molar mass. Okay, so for example, 1 mole of ammonia equals 17 grams. O, di ba? Kanina, tinignan natin, 1 mole of carbon equals 12 grams. Diba? So, ito, yun lang naman ang nabago doon. But all the other calculations, all the other ways to determine the number of moles, to determine the number of molecules, etc., pareho. The same as the examples that we had earlier. Okay? So now, will you try this? I'll give you a few minutes to try this on your own. Yan. Sige. I'll give you a few minutes, siguro mga 5 minutes to do that. Oh, sobra pa nga yata yung 5 minutes eh. Sige. The first statement in number 1 is just parang pasakalya lang. It is giving you a description of what helium is. Okay? But the main question here is how many moles of helium are there in 6.46 grams of helium? O, sige nga. Let's see. Anybody? One? Really? Oh, 1.61 mole. Okay. Miss 1 times 10 to the 23? Oh my God. Dami nun. Okay, 1.61 mole is the correct answer. Okay? 1.61 mole. Ano yung factor na gagamitin natin dyan? 1 mole of helium equals 4.03, something like that, or 4. Okay? Oh, that's the molar mass of helium is 4 something. Okay, 4 point something. So it's more like 1.6 or 1.61. That's the correct answer. Okay. Now don't forget to write the unit 1.61 mole. Okay, now number 2 problem is much similar to number 1. So let's jump to number 3 because number 3 is a problem on a that gives asking for a compound this time, a compound. So nga, what is the mass in grams of 2.5 mole of H2O? Oh, come on, give me an answer. Anybody? Sige. Number three na sagutan niyo. You can just do number 2 on your own later on. Let me see for number 3. Okay. Anybody? What is the mass in grams of 2.5 mole of H2O? Anybody? What is the molar mass of H2O? 1 mole of H2O equals how many grams? Try again. Try again. 1 mole of H2O equals how many grams? Sige, sagutin niyo muna yung tinatanong ko. 1 mole equal, H2O equals 18.02. That's correct. Okay, so that is for 1 mole. 2.5 mole yan. So, how many grams is 2.5 mole of H2O? If 1 mole equals 18.02 grams. Okay, very good. Very good, Randy Galoso. 45.04 grams. O, try again. Try again yung iba. The correct answer is 45.04 grams. Okay? So, ganun lang. 1 mole H2O equals 18 grams. Diba? So, 2.5 mole multiplied by 18 grams divided by 18, 18 grams over 1 mole. So, that gives you 45.04 grams. Okay? How did you get 38? Shayna? Ang hirap Ang hirap pagkaganito lang. Dapat ito may board and ano. Okay, the correct answer is 45.04. Okay? All right. All right. So, let me that ends our discussion. Now, class, there are other exercises. Maybe in your module you'll find some more similar exercises. You work on them, or if you have questions, you can chat me in our chat group sa ating LMS. Okay? And I hope you find time to do some more of these exercises at home or in your own para ma-practice kayo. Now, this is just an initial part for our discussion of stoichiometry. So, next time, so wait, let me just so that ends our discussion for today.